Hello students, let us discuss the reaction of haloalkanes with metals. As we have classified the reaction of haloalkanes in four categories, that is nucleophilic substitution, elimination reaction, reaction with metals and reduction. From this, the first and the second we have already discussed in the previous video. Let us discuss the third, that is reaction with metals. So in this video, we are going to discuss reaction with metals. Active metals like sodium, magnesium, cadmium, lithium, etc. easily combine with alkyl halides and give rise to the product which is called as organometallic product. That means the product which consists of carbon-metal bond is called as organometallic compound. So, for us in the syllabus, there is a reaction with sodium and reaction with magnesium. So, we need to discuss the reaction of alkyl halides with sodium and magnesium. Let us discuss first reaction with metals, that is sodium metal. This reaction is a name reaction which is called as Wood's reaction. Action with sodium. Two molecules of alkyl halide may be same or different, react with metallic sodium in the presence of ether to form alkanes. This reaction is called as Wood's reaction. Let us learn the general equation. That means alkyl halide, which I am representing alkyl halide with the Rx. Sodium metal, that is represented by symbol Na. Rx is represented here and plus twice Na plus Rx. I am writing the second molecule of Rx in this way so that we can make the product very easily. That is Rx I am writing as XR. Now how we make the product here? Here there is a removal of 2 sodium and 2 X. That means this bond will break. Here this bond will break and there is a formation of a side product, that is 2NaX. So 2NaX will be a side product formed here and the remaining one will form the major product, that is one R is remaining here and one R is remaining here. So when this part, that is 1X, 2Na and the other X will be removed as the side product 2NaX, at the time this R and the second R, that means two alkyl group get binded together to form product, that is a hydrocarbon. So same equation you can write with CH3X. If I am taking R as CH3X, so I am writing the equation like this. R can be taken as CH3, X can be taken as Cl. So our product formation will be takes place in this way. That is R can be written as CH3 Cl plus 2Na plus Cl CH3 give rise to CH3 plus 2NaCl. Here R is CH3. So here first we have taken one carbon atom alkyl halide and we are getting 2 carbon atom hydrocarbon. That means methyl chloride is taken and the product is ethane. So in this case, in this type of reaction, the number of carbon atom in the organic compound can be increased, or we can say that we can nearly double the number of carbon atom. If one carbon atom is taken in the reactant, we will be getting 2 carbon atom in the product. So that is a Woods reaction. Let us take one particular example. That is C2H5Br plus 2Na plus BrC2H5. I told you the second molecule of alkyl halide, the same alkyl halide, you have to write in this way so that we can easily frame the product. That is removal of one Br from here, 2Na from here and 1 Br from here. So total there is a removal of 2 NaBr and the product formed is, that is the alkyl group, this alkyl group C2H5 and C2H5 get bind to form butane. So this is the formation of product, that is the hydrocarbon. This reaction is called as a Woods reaction. So Woods reaction, when the alkyl halide, which can be same or different, in this case we have taken same alkyl halides, react with the metallic sodium in the presence of ether to form alkanes. Alkanes are the hydrocarbons. Let us take some more example. When we take a primary alkyl halide, that is C2H5I plus twice Na, we get C2H5, that is total 4 number of carbon atoms are there in a alkane. This is an alkane, is a product, that is butane. In the second case, CH3I plus twice Na give rise to CH3, that is 2 carbon hydrocarbon alkane, that is ethane plus 2 Na. So this is in the case of primary alkyl halide. Let us take secondary alkyl halide. In the secondary alkyl halide, this is a secondary. How it is a secondary? Because this is an alpha carbon and there is neighboring carbon, that is beta carbon. So there are 2 beta carbon here. This is a beta carbon, this is a beta carbon. So 2 beta carbons are there. It is a secondary alkyl halide. Now when we are doing the Woods reaction for secondary alkyl halide, first of all, write the structure in a particular way so that it will be easy to frame the product. So I will show that how we make this in a comfortable way to make the product. That is, better you change this Cl here and write the CH3 down, because it will not going to change the molecule when you are changing the position of Cl on this side and CH3 down, because still the compound will be the same as it is. So why I am changing this Cl on this side? Because in order to make the product, side product with the Na easily. So when I shift the Cl and CH3, I'll be getting the reactant in this way. So now I change the position. So in this you can find out Cl is here, and this whole structure we have to write it in the reverse order. You can see this structure and this structure are same, but the way of writing is different here. This is only we are writing in order to make the product more easily. So let us make the product for this one. So here there is a removal of 1 Na. This is 1 Na. So 2 Na is taken. 1 Cl from here. 1 Cl from here. So total 2 NaCl is removed as a side product. So the rest of the part, that means this part and this part, will be get binded. So when it get binded, so how you make this part, the product, just remove this part and make a bond between them. So the product is ready. So we can check the product. This is the product which is formed. That is a hydrocarbon. It is an alkane. Next example. Before that, you can check the product of the product which is formed when sodium is treated with a secondary alkyl halide. The next one, tertiary alkyl halide. In the case of tertiary alkyl halide, there is no possible product here because this reaction, that is for tertiary alkyl halide, the reaction with sodium get failed. So it does not happen, this type of reaction does not takes place for tertiary alkyl halide. So now let us discuss with reaction with magnesium. Reaction of haloalkanes with magnesium. When a solution of alkyl halide in dry ether is treated with magnesium, an alkyl magnesium halide is formed. This alkyl magnesium halide, it can be represented by RMgX, which is known as Grignard reagent. That is RMgX. The product formed here is alkyl magnesium halide, which is commonly called as Grignard reagent. Grignard reagent, which is represented by RMgX, it is one of the important class of organic metallic compounds, which is known as Grignard reagents. These were discovered by Victor Grignard, a French scientist, a chemist, in 1900 and are named after his name. For this discovery, Grignard got the Nobel Prize in the chemistry 1912. This compound have a great variety of synthetic application and useful in the preparation of large number of organic compounds. Let us discuss Grignard reagent structures in detail. Grignard reagent, which is represented by RMgX, where R is the alkyl group, Mg is the metal, and X is the halogen. Here there is a special type of bonding. In this, the carbon of alkyl group and the magnesium together, there is a bond formation between them, that is a polar covalent bond. It is a covalent bond, that means the bond is formed by the sharing of electron between the carbon of alkyl group and with the magnesium, that is covalent bond. Because there is a electronegativity differences here, that means magnesium is more electropositive, so it develops a partial positive charge, and the alkyl group, that is carbon here, it develops a partial negative charge. So we can say that there is a electronegativity differences between the carbon and magnesium. It develops a partial positive charge on the magnesium and partial negative charge on the carbon atom of alkyl group. Therefore, this group bond is polar covalent bond. In this, the bonding between the magnesium and the halide is a ionic bond. So, in a Grignard reagent, there are two type of bondings are there. That means a polar covalent bond, which is found between the carbon of alkyl group and magnesium, and a ionic bond between magnesium and halogen group. So carbon magnesium bond is covalent and it is very polar, which you can see in this figure. R is represented as CH3. So the carbon develops a partial negative charge, magnesium develops partial positive charge, and carbon is more electronegative than the magnesium. Here the magnesium halogen bond is ionic. Let us see how it is named. Let us look at the nomenclature of Grignard reagent. Grignard reagents are named like this. First of all, we will discuss the name for the general equation, that is RMgX. What is R here? R is alkyl group. Mg represent for magnesium and X represent for halide. So what is the name for this general formula of Grignard reagent is alkyl magnesium halide. Look at the structure properly and name it. R is for alkyl, Mg magnesium, X halide. Let us take a particular example for naming. CH3MgCl. Here R is methyl group. So instead of saying alkyl, we'll use particle word, that is methyl. CH3 is methyl, Mg is magnesium, Cl chloride. So if CH3 Mg Br is there, then how we name this one? Methyl magnesium bromide. If in the place of CH3, if it is C2H5, then how we name this one? C2H5 MgCl, then the name will be ethyl magnesium chloride. So depending upon what we have the alkyl group in the Grignard reagent, you have to name that alkyl group. If it is methyl, you have to say methyl, ethyl, propyl, whatever it is. Even it can be a cyclic part also, like cyclohexyl, cyclopentyl, anything. So you have to name as it is that group, then the magnesium, and then the halide part. Halide can be chloride, bromide, iodide, etc. So this is the nomenclature of Grignard reagent. Grignard reagent react with any source of proton to form hydrocarbon. That means when the Grignard reagent, which is highly reactive compound, it can react easily with any of the compounds which is a source of proton. Source of proton means which can give proton easily. Then it gives a product called as hydrocarbon. So how we make this product? In this case, this bond will break. That is the bond between RMg break. One H, that means H will be taken by the alkyl group and OH will be taken by the MgX. So we get product RH. RH means alkyl group plus hydrogen, that is hydrocarbon. So let us take one particular example. If R is our methyl group, if it is R is CH3, MgX, I am not writing fully, our R is CH3. So at that time this bond will break, one H on this side. One H on this side means CH3 and one H, that is CH4. So the methyl group get converted into methane. That means the formation of hydrocarbon, that is alkane, is formed here. So why it happens? Because Grignard reagent is very reactive. Because of this reason only, it is very necessary to avoid even the traces of moisture from a Grignard reagent during its preparation, because these react readily with the oxygen and carbon dioxide. Therefore, these should be prepared and used in the absence of air under the inert atmosphere. That means whenever the Grignard reagent is prepared, it should be prepared in the absence of air. That means under the inert atmosphere. So in this video, we have discussed the reaction of haloalkanes with metals like sodium, that is a Woods reaction, and the next reaction with magnesium, which gives a product Grignard reagent, which is a quite important and reactive product, and you'll be getting a number of equations related to Grignard, and it is one of the most important reaction for the exam purpose, both the reaction. As Woods reaction is one of the name reaction, so you have to add it in the list of name reaction. Thank you everyone.